Okay, Unit 7, Day 6, we're going to do things a little bit, kind of change the pace here from what we were doing. We're going to give you 2 points, and you got to try to find the exponential curve that goes through those 2 points. Okay, so it's pretty easy to find a curve that goes through one of the points, but to find a curve that goes through both points, that takes a little bit of work. It's based off like 2 ideas we've done, before in your math career. You plugged into an exponential. It's what we've been dealing with right now. You think of y equals a b to the x. We know the standard exponential form. And then also, if I give you 2 equations, think of it as a system, and you need to solve for x or y. So we want to eliminate. We can use elimination. In this case, we're going to use substitution. There is really no elimination when you're doing exponentials. With 2 linear equations you can, but with 2 exponentials, it's substitution is pretty much your best bet. So let's start off with each one of these points, plug it in. So this is an x coordinate and this is a y coordinate, okay? And then this is another x coordinate, another y coordinate. So just looking at this first one, if I plug 0 in for x, I should get 7 for y. So if I plug that in, 7 equals a b to the 0. And b to the 0 is 1, so that means 7 equals a. That's really nice how that worked out. When we give you, so this is also a y-intercept, because the x is 0, so go right 0 up 7, that's a y-intercept. If I give you the y-intercept, that's actually the easier kind of problems there are. Now I'm going to do it again with this number right here. So when I plug in 56 into y, I get a b to the 3rd. Okay, so a times b cubed equals 56. Now, a equals 7. Okay, so I could actually do substitution here, plug in 7 right there. So 56 equals 7 times b cubed. So I did that substitution. Now it's just one variable to solve for. I need to solve for b. Now once I have a and b, I can write an equation. That's our learning target too, is I can find the equation of an exponential curve that passes through these 2 points. So we're going to try to do it that way. So this divide by 7, so 8 equals b cubed. If I cube root both sides, that means b equals 2. Okay, so if a is 7, b is 2, then that means y equals 7 times, and this would be 2 to the x power. If you want to check that out and make sure that's right, you can, on your calculator, let's graph that. So 7 times 2 to the x. If I graph it, let me get a better screen than that. It's going to kind of go off. That's okay. Let's see what we get. Well, in fact, I could do trace. When I plug in 0, I get 7. What happens when I plug in 3? I should get 56. Let's see if it goes off. Yep, it stayed on here, so 56. Sometimes if your cursor goes off the screen, it won't tell you the answer, but when I plug in 3, I get 56, so that goes through that point. So there's my exponential curve that does it. Now, whenever, this guy, I'll go a little bit faster, because notice I gave you a y-intercept, so it's going to have the same thing happen here. When I plug into y equals ab to the x, I'm going to get 5 equals ab to the 0, which just means that a equals 5. Now I'll plug this one in, 320 equals ab to the 3rd. We'll plug in 5 in for a, so 320 equals 5b cubed. If I divide both sides by 5, I get 64 equals b cubed. I cube root both sides, so 4 equals b. So I got a is 5, b is 4, plug those in. Y equals 5 times 4 to the x power. And you can check yourself with a calculator. Now I want to create an exponential equation that passes through these 2. Okay, so I want to have it go through those 2. Neither one of them is a y-intercept, so that makes things a little bit more difficult. I'm not going to get just a equals like this, because I'm not taking b to the 0 power. There's no zeros here. So I've got to do a little bit more work. That's okay. So this one would be 16 equals ab to the 2nd. And then using this guy, 256 is going to equal ab to the 6th. Okay. What I need to do now and it's probably easiest to solve one of these equations for A. Get A by itself. Don't get B by itself. Okay, it's going to be easier to get A by itself. Okay, I would do the one with smaller numbers. So looking at this guy right here, I would say that A equals 16 over B squared if you divide the B squared over. So these are equivalent equations, but anywhere I see an A, I can plug a 16 over B squared, so go to the other equation. So it'd be 256 equals, and then for A, take A out and plug in 16 over B squared in its place. Okay, so now, when I'm done simplifying, there are no A's. I did my substitution, I got rid of the A's, now it's just B. I need to solve for B, get B by itself. So 256. Now, if I think of these as fractions, I've got B over 6 and then 16 over B squared. Well, B squared and B to the 6th, two of these will cancel two of them out. Okay? Or you can think of it as, since the bases are the same, you take 6 minus 2 and get 4. So it'd be 16b to the 4th when I'm done. The 16 stays, so 16 on top does not do anything with 1, but b to the 6th and b squared reduced to b to the 4th. Now solve for b. So divide by 16. So b to the 4th is going to, let's see, if I divide by 16, that is 16. And then take the 4th root of that. So b equals 2. Because 2 to the 4th equals 16. So now I have my b, I need to find a. Well, go back, you have a by itself right here, plug in 2 and for that b. So I'm going to plug that into 16 over, and instead of b squared, I'm going to have 2 squared. So 16 divided by 4, because 2 squared is 4, 16 divided by 4 is 4. So a equals 4. So I got b equals 2, a equals 4, y equals 4, 2 to the x power is my equation. Okay. Next one. Now I'm just going to kind of go a little bit faster. It's going to be the same thing. Same process every time. Write them both down. Write them both down. Solve the one with smaller numbers. Solve for a, and then plug it in and solve for b and go from there. So a little bit quicker now. I'm going to plug this in. I'd have negative 2 equals ab to the negative 1 power. Now, if I wanted to rewrite this, well, maybe I'll do this. So let's just write the other one down. So I'll plug this in too. So negative 162 equals ab to the 3rd. Now this guy is a little confusing, but when I have b to the negative 1 power, that's not actually in the numerator, it's in the denominator. This is the same thing as b being on bottom. This is the same thing as negative 2 equals a over b. Because when I bring it to the bottom, the exponent becomes positive. So it'd be b to the positive first, and when I want to bring it over, I need to multiply the b over. So it'd be negative 2b equals a. So anytime you have b to the negative 1 power on one side, you can actually move to the other side as a positive 1 power. Because you're going to move to the bottom and then multiply it over, you'll get this. So now I got a by itself, plug it in for this a. So negative 162 equals negative 2b times b cubed. So take the a out, put negative 2b in its place. Negative 162 equals negative 2b to the 4th, divide by negative 2. So I get 81 equals b to the 4th. Take the 4th root of all of that. So b is going to equal 3. So b is 3. Now plug it in the equation. We have a by itself, plug it in for b. So I'm taking this one right here. So negative 2 times 3 equals a. So a is negative 6. So y equals negative 6. 3 to the x power. Okay. Let's see here. Maybe I'll let you. Yeah, I'll let you guys do this one. I'm gonna keep the video going here, but try this one. You get 18 and then 1/3 to the x power. You do end up getting the b as being a 1/3 when you solve for that. But yeah, if you want to see that in person, let me know. Just raise your hand, let me know. But if you want to just try it out real quick, plug it in and see what you get. I don't want this video to run too long. Now on the back side, we got some application problems. So how can I do this? So suppose there's 400 deer in some nature preserve in 2010, and then this year, 2021, there are 750 deer. So what is the deer population in 2030? Now, this is not going to be a nice, neat whole number answer. The ones in the front, I gave you order pairs so that A is going to be a whole number, B is going to be a whole number. This problem actually changes every year I teach this class. So this problem is going to be a little different than last year's notes, but my B especially is going to be different. Okay, so what we're going to do is you could say that in the year 2010, comma, there's 400 deer, and that's fine. I think it might be easier, instead of saying 2010, let's say X represents the years after 2010. So if I let X represent years after 2010, which basically makes that year 0, then this coordinate is going to be 0, 400. So no years after 2010 there were 400 deer. This year, which would be 11 years later, there were 750 deer. So let's use those points. And the reason why I do that, I would love to have a y-intercept. I'd love it if it was 0 because it's going to make my life easier. Because when I plug this in for x and y, I get 400 equals a b to the 0. Oh, sorry, my video froze. There we go. B to anything to 0 power is 1, so this is just a equals 400. And you might, for those of you who remember, that the number that goes in for a is the initial value. Well, this is when we started keeping track of it in our problem, so that could be our initial value is 400. That makes sense. Now, for the other problem, 750 equals a b to the 11th. So if I plug in 400 in for a, so 750 equals 400 b to the 11th, divide 400 over. So b to the 11th is going to equal this number, which I'm actually just going to leave it in there as a number. I'm going to take, so I'll just put 750 over 400 in my calculator, do this all at once, to take the 11th root. So how you take the 11th root, get the glare off here. If you do, let's go to math and go down to this one right here. This is the xth root. Okay, so if you have an older or a newer calculator, it'll say, okay, now what root? Now the new calculators, I don't know how I said that. The new calculators do this. The older calculators, you have to actually hit your root first. So let me type this in here, and then I'll show you how to do it on one of the other calculators. I got 750 divided by 400. I can just put parentheses, 750 divided by 400, all in at once. So I'm taking the 11th root of whatever this number is. Whatever my answer pops out, that's my B. So 1.059 or so. Now, if you got an older calculator, if you do math and then this button, it thinks you mean whatever your previous answer was, that's your root, and that's not what we want. We want the 11th root, so you have to go 11, then push math, then math, and on down to number 5. So the 11th root of, and then parentheses, 750 divided by 400, end parentheses. So it needs to be typed in exactly like that if you want the 11th root of this fraction. So 1.059. So now my equation is y equals 400, that's my a, and then my b is 1.059 to the x power. And they want to know the population of the deer in 2030. That'd be 20 years later. So I'm going to plug a 20 in up there. So let's do 400, and then parentheses 1.059 raised to the 20th power, because 20 years later. So if I plug a 20 in there, I get 1258.87. Well, we'll say 1259 deer. Okay, so that was just plugging in. I'll say, here's my work, 400, 1.059 to the 11th, I'm sorry, the 20th power. Put the 20th in there. Okay. So, yeah. And then the next one, sort of the same idea. I purchased a car in 2013. It's worth $9,600. So we could call year 0, 0, but why not call 2013 year 0? Okay, just make my life a whole lot easier. So we'll just say X is years after 2013. So in year 0, it's worth 9,600. And that allows me to say that 9,600 equals A, B to the 0, which just means 9,600 equals A. Whoops, A. Makes my life a whole lot easier. Now, 5 years later, So 5 years later, after 5 years, it's worth 4,200. Okay, so that'd be 4,200 equals AB to the 5th power. I already know what A equals. A equals 9,600, B to the 5th. So I'm going to divide by 9,600. Let's cross that out. And then I'm going to take the 5th root. So in my calculator, let's type it all at once here. Save some space, or save some time. So if you have an old calculator, push 5, which I can do that, 5, and then go down here. It automatically fills in for me. The 5th root of 4,200 divided by 960. I'm sorry, 9,600. If you have an old calculator, put that in parentheses. Okay. So the 5th root, and then make sure this is in parentheses. Okay, 4,200 divided by 9,600. Okay, and it makes sense this number is less than 1 because this is decay. It's losing value. The deer up here were growing. The population went from 400 to 750. That means this B should be greater than 1. This one, it's losing value, so it should be less than 1. So my B equals 0.84, we'll say 848. So Y equals 9,600, 0.848x. Now what will it be worth in 2023? Well, that's 10 years later, so I'm going to put a 10 up there. So let's put that to the 10th power. So 9,600.848 to the 10th power. So 9,600.848 to the 10th power. About $1,045.99. Okay. So yeah, so hopefully that's not too difficult. If you have any questions on it, just mark it and ask me when you see me next, and yeah, make sure you do your homework.